Hello, grade 10. Today I'll be doing the week 2, term 2, week 2 math CA quiz. I'll also be doing the math periodic revision as well. But I'll start with the AMS because it's all just in 10 questions. So I'll start here. The finite region bounded by the curve y equals fx. Fx is equal to x square root, and then enclosed in that is 3 minus x squared. And then now in this curve here, we want to find the volume of a solid. Look, if we read here closely, it says that there's the region. It's bounded by the x-axis 1, x equals minus 1, which is a vertical line, and x equals 1, which is another vertical line, and it's rotated about the x-axis. If they say it's rotated about the x-axis, then we must keep fx as fx. If it says about the y-axis, then we must do the inverse and then derive with respect to y. But right now I don't think that it's not. I don't think it's gonna pop up in this quiz. Okay, so and also we haven't really discussed the topic from like that like from earlier on. So for now we're just doing like rotating about the x-axis. Okay, so normally when you do area, you have like you have to find like certain separate boundaries. Like look, I'm pretty sure the curve has a shape like this, something like this. And some might think that you have to find the area of these two separate areas. Like over here is minus square root of 3 and over here is square root of 3. And then you have to find the volume rotated about this and then the volume rotated about this and add them. But that is unnecessary since like the formula to doing this when rotating about the x-axis is first pi, then integral, the limits that are given to us, that are given to us, yes, are x equals minus 1 and x equals 1. So we just set the integral simply to minus 1 to 1, and then we put fx squared. And if you see the pattern, you notice it's like saying pi r squared. And then it's just, and then you just put an integral, and then you just put the integral next to it, and then you extract the pi because it's a constant. Okay, and with respect to x, now we derive it. We first plug in the formula. Let me just give more space. Okay, pi minus 1, 1, x square root of 3 minus x squared. Yeah, that's that, dx. Now, first I'll square everything. I get this. And then I will distribute the x squared to get this. Now I'll integrate to get x power 3 minus x power 5 over 5. No need to apply the constant c given that we're finding the volume and not just the definite integral, just this. Okay. Now what we'll do is don't forget the pi, of course. We'll add the pi later. We'll focus on this part right here. So it's gonna be, you plug in 1 into x first, and then you subtract that by x substituted by negative 1, which is the lower number, like this. And then you should get, wait, we can even do this off here. So 4 over 5 minus, and then over here it's minus 1 plus 1 over 5, so minus 4 over 5. And then that's equal to 4 plus 4 over 5, which is equal to 8 over 5. And then we have to apply the pi. So now our volume is 8 over 5 pi cube units. So the value of k, 8. Moving on. Now this one is super simple. We'll first rewrite the integral that they gave us. Over here, they gave it to us like this. I'll just put the denominator back into the numerator, and I'll just change the exponent into a negative form. So 40x 2x squared minus 1 to the power of minus 2 dx. Okay, now look, they said w0 minus w1 over here. Now there's two ways you can do this. You can either just simply set the boundaries, like actually you can set it 1 to 0, or you can separately do the integral and then you can set the values. I'll choose just simply setting the values, like how they say in the hint here, where they actually first find the indefinite integral constant c. So u is equal to 2x squared minus 1. This is called the u substitution method. We take whatever thing that we find hard to expand with the negative exponent, or anything that's too large for us to expand. So what we do, we take a constant u, and we want it so that we have only u in here, and dx becomes du. And once we do replace it with u, it should become simpler. I'll show you what I mean now. So then you derive u with respect to x to get 4x. Now you isolate dx, so then we can substitute it with du, and we get dx is equal to du over 4x. Now, over here, we'll repeat what we just wrote, except with the given information. First, this one. This given information is given. Okay, 40x, and instead of 2x squared minus 1, we'll just put u, and then to the power of minus 2. And then instead of dx, we'll put du over 4x. Then we'll divide 40x divided by 4x is equal to just 10. It's a constant, so we can take it out of the integral. And then we integrate, and when you do everything, you should get minus 10 over u plus c is equal to wx. Okay, what you do then, given that u is equal to 2x squared minus 1, now we'll just bring it back to back everything in terms of x. So this is also equal to minus 10 over 2x squared minus 1 plus c is equal to wx. Now they're asking for w0 minus w1. So what we do, we set w equal to 0, and then we set w equal to 1. W equals 0 is minus 10 over 0 power 2 minus 1 plus c. This will be equal to 10 plus c. W0 is equal to 10 plus c. Then they're asking to subtract it by w1, which is equal to 2 minus 1, and then you get, instead of positive 10, you get negative 10. So you get negative 10 plus c. So now we have w1, and now we have w2. And now we have w0. Now we just subtract these two. Given that these c's are equal, they'll probably just cancel out during the process. So let's see. Okay. So we distribute the minus. So yeah, we cancel them. And then we only have to add 10 plus 10, which is 20. I'm using the hint over here as given. I'm using the hint as an example. So 10 plus 10 is 20. Moving on. Okay, now this is a simple definite integral question. So we have minus 2 to x cubed minus 15x squared dx. Now this comes with, I think, 3 very easy steps. Step 1, integrate the inside. It's going to be x power 4 over 4 minus 15 x power 3 over 3, which is equal to 5x power 3 dx. No, actually no dx. We're done. We derived it. Now we just set the values ranging from minus 2 to 2. So you substitute 2 power 4 over 4 minus 5, 2 to the power 3, minus, and now you substitute x with minus 2. And then you get the top here will be 8, so 2 minus, and then 8 multiplied by that is, okay, 8, and then we have plus 40. So we have 48 minus minus 32. And then if you add these up, you'll get 80 minus 80. Oh, sorry, I did a slight error here. I accidentally said 2 power 4 over 4 is 16, is 8 over 4, but it's actually 16 over 4, which is 4 here. So 4 minus 40 is minus 36. And then over here, instead of 8, I don't know why I put 8. Why did I put 8? I have no idea. So 16 over 4, which is again 4. And then now we have 44 over here. So minus 36 minus 44. We still got minus 80, but that's just completely coincidental. Okay. Moving on. So over here we have we're asking for the area under the area of the enclosed region, or the shaded region simply. Now look, we have two areas where there's this shaded region. We have the area that's above the x-axis and below the x-axis. If it is above the x-axis, then when you do the integral, the value is gonna be greater than 0, and when you do the integral in this boundary here, it'll be less than 0. So in this case, what you do is you have to do two separate regions. This is in the case of when you're finding the area of an enclosed region, depending on if it's the x and y axis. And sometimes if it's enclosed by two curves, then you don't need to do this step. Okay, so simply we'll start with the integral. We'll start with this region 0 to 2, and then we'll do 2 to 3. So what's our graph again? Y is equal to x minus x squared over 2. And then we'll start with the boundaries 0 to 2. So easy as that, 0 to 2, x minus x squared over 2 dx. Let me just see here, yes, it's like that. Now first you integrate the inside, you get x squared over 2 minus x cubed over 6, ranging value 0 to 2. Just substitute 2 of this 0 as the lower term. No need to do the other one. I mean, unless it's written, then it's best if you just plug in the value 0 power 2 over 2 minus 0 power 3 over 6. You'll just end up getting only whatever this value stands for. So in the computer exam, you might as well just write it like this, like without this. In the written, I guess safer. That's the safe route. Okay, 2 over 3 is the area over here. 2 over 3 square units is the area in this region that I am showing right here. Okay, now we have to do this region over here. This region over here, where the boundaries are now 2 to 3. However, it is under the x-axis. So if it is under the x-axis, what we must do is integral, same thing, except when we're integrating from ranges 2 to 3, it's under the x-axis. So what we can either do is multiply by minus, or just put absolute value. Minus is just more convenient, right? 3 over 2, and then we write the same curve, x minus x squared over 2 dx. And then you have the integral, and then you set it to these values. It may be negative. Now we already set the substitution of 1 is 2, and it was 2 square root of 3. So what we'll have here already is 2 square root of 3, I believe. Yeah. Okay, we'll first plug in 3. So minus, everything's minus. We'll just go with the inside and then we'll multiply everything by negative. So we'll substitute x with 3 first. So 3 power of 2 over 2 minus 3 power of 3 over 6 minus 2 power of 2 over 2 minus 2 power of 3 over 6. This one is equal to 2 over 3. And this one over here is, let me see on the calculator, 0. Okay, so over here is 0. So 0 minus 2 over 3. Wait, it's not necessarily minus 2 over 3. It's just this and then minus that. Yeah. Oh god, sorry. Sorry, ignore that error. And then you get, and then remember, now we're just gonna bring that negative that we were meant to multiply with, and then we get 2 over 3 as the area of this region over here. So now we have two areas, right? We have 2 over 3, and we have 2 over 3. These are the area of both the regions, respectively. So now we just add the area of both of those regions to get the total area of the shaded region, which is 4 over 3. Thus, the value of k is 4. Okay, so we have x cubed and 16x, 2 lines and 2 curves enclosing. So first, what we want to do is find the intersection points, but over here they've already clearly stated them. It's x equals 4 and x equals 0. Okay, so there's a rule. Like there's a way it works. We basically find the area. You do the integral and then upper curve minus lower curve. However, the way it works is you find the area under this line and then you subtract it by the area under the curve, and then you get just the area of the shaded region. That's how that method works, and that's why you do upper minus lower. Okay, we'll just keep it simple and we'll do it that way instead of splitting it into two separate integrals. So upper, in this case, the upper line over here, this is above the shaded region, and it's line 16x as shown here. 16x is line. So 16x minus, and then the lower curve, which is x cubed, dx. And the boundaries are 0 to 4, as shown over here, 0 to 4. We first integrate it, we get 8x squared minus x power 4 over 4, 0, 4. And then you just simply plug in 4 in here. Minus 0, but again, we're not in the written, so, this time I won't really write it. Okay. Minus this, and you get 64 over here. So the answer here is 64. Okay, so now we're in question 6, and I've prepped everything for this question. Now, when the question is coming inside the AMS, it's probably going to be different, and it's going to be a lot easier than this, since they give the values for examples over here, and all you have to do is like the values over here, and it's so easy to get. You just have to integrate the second term over here twice. But in this case, we're going to have to solve the full thing the proper way, and we should know the following. The derivative of the second is the integral of the second derivative is equal to the first derivative, and the integral of the first derivative is equal to the initial graph, equation, function, whatever. So we'll start with integrating the second derivative to get the derivative, and then we'll derive the derivative to get the y formula. So we have 6x minus 18 integrate with respect to x to get dy over dx. So I'll just integrate it. I'll get 3x squared minus 18x plus c. Okay, so now what I'll do here, I have constant c. I'll call this c1 because we'll be deriving twice, there'll be two constants. And this is equal to dy over dx. Now, if we want to continue integrating even further, we must first find constant 1. Now I've written this over here. Now where did I get this from? This one little part here. This curve here has a stationary point at 2, 3. The word stationary point is very important. Because when they say stationary point, there's two things needed to be pointed out. Number one, this curve is on the graph. And second, the tangent on this point on the graph is 0. Or sorry, the slope of the tangent on this on that point of the graph is 0. So over here, this is why I stated that the derivative when x is equal to 0 is 0, because stationary points, st points, have make dy over dx equal to 0 once you substitute the x value in them. And over here, stationary point 2, 3 is also just a simple point on the curve. So like x is the input, y is the output. And that's why this answer over here is this statement over here is also valid. Okay. So now I'll set the derivative at x equals 2, and it must be equal to 0. So dy over dx, when it's equal to 2, as shown here, over here it says the stationary point is x equal to 2. So I'll just plug in 2 in here, plus c1, and it must be equal to 0. So 3 power 3, 3 multiplied by 2 power 2, 4 times 3 is 12, minus 36. So c1 is then equal to, therefore, 24 after calculation. Sorry, no, not 20, yeah, 24. So c1 is equal to 24. Therefore, now we can rewrite dy over dx is equal to 3x squared minus 18x plus 24. Now we need to know this full formula later. Okay, so now that we have this, we'll integrate one last time, so then we can now get the original curve formula. So dy over dx is equal to just y. So I'll just integrate this over here. Integral of 3x squared minus 18x plus 24 dx is equal to y. Okay, so I'll simply integrate to get x cubed minus 9x squared plus 24x plus c2, which is our second constant. And this must be equal to y. And this is equal to y. And now now that we've already used this thing and we put it to use, now we'll use this thing here. When x is equal to 2, over here, y is equal to 3, and as shown here. Okay, so I'll put the value of 2 here. When y is set to x equals 2, we can write this. And when x is equal to 2, y is equal to 3. Now I'll just simply put this on my calculator. Okay. Therefore, c2 is equal to... Wait. I got over here 20. 20 plus c2 is equal to 3. Thus, c2 is equal to 3 minus 20, which is equal to minus 17. Therefore, this is our answer here. Now we can just write the full formula, and it's going to be x cubed minus 9x squared plus 24x minus 17 is the final answer. Now, you might think, this is like easy, we can just, in the exam, you just put the value over here by just integrating or deriving once, but this might possibly come in the written, since it is a course practice, it is a course revision question. So the answer here is minus 17. Okay, so the x-coordinate of the point of the local minimum on the curve is x equals blank. Okay, now we saved the formula of the derivative over here, thank goodness. And when you find the x-coordinate when you're trying to find the turning points, dy over dx must be equal to 0 for stationary points or turning points, as I stated here. Stationary point make the derivative equal to 0. So, dy over dx is equal to 0. Therefore, I have dy over dx, dy over dx's formula, which is 3x squared minus 18x plus 24 is equal to 0. I can factor out the 3 and just cancel it on both sides. I get this. And I just do simple factorization, and I get x minus 4, x minus 2 is equal to 0. Therefore, the turning points are x equals 4 and x equals 2. Now, there's two ways to do this, with one being easier. One way, which is the harder path, is by just doing the table, which is much more difficult, and I prefer not to do this method, since there's another method that is given, and it's much easier than this method, and that is using the second derivative. Now, how can this help? The second derivative determines at a specific point whether the curve is concaving downward or upward. Like, for example, maybe at x equals 2, it is concaving downward. At x equals 4, and at x equals 4, it might be concaving upward. And to determine that, if the second derivative is greater than if the second derivative is greater than 0, then then the nature of the turning point, or any point or any x coordinate you put input in there is minimum, or the curve is concaving down. But in this case, when it's a stationary point and it's concaving down, then it's a minimum. When dy when the second derivative is less than 0, then it is a maximum. Okay, so now I'll just input the values here. I'll set no, I already have the formula here, right? 6x minus 18. So I'll put x equals 2 minus 18 equals minus 6. Now minus 6 is less than 0, meaning what I put here, right? I put x equals 2, and over here, this follows this rule here. The second derivative is less than 0, therefore the nature of the stationary point is maximum. So at x equals 2, it is maximum. So over here it's stating maximum, so x equals 2. And then there's the other turning point. No need to waste time by substitution. Just put 4, since that's the only other turning point. Okay, now moving on. We have the acceleration. Okay, now we should know this. This is now applying speed and just distance and all of that. We should know that the integral of, think of acceleration as the second derivative of displacement. Think of, look, this is how it will be. Okay, v representing the velocity and x representing, or s sometimes representing the displacement. Okay, so over here this shows that I integrated twice to get s. Here it shows that I integrate once the velocity to get s. Okay, now that we have these in mind, we're given the integral. Now we're given the area. The acceleration 12t minus 2. Well, now normally, not normally. Just right now, we'll behave as if t is now x. Okay, so and we'll behave as if a is like saying d squared y over dx squared, or the second derivative. Okay, so if at t equals 0, the velocity, the v is equal to 3 meters per second, then at any time t, v is equal to whatever. Okay, so we'll just simply integrate. The integral of acceleration is equal to velocity. So we'll just integrate 12t minus 2 with respect to 2, and then I'll get 60 squared minus 2t plus, and then over here, since it's no, right now we're not doing mechanics over here. We'll just keep it simple here. This is just our velocity. Our constant c here, normally it's supposed to be, I believe, the initial velocity. Okay. So now they said that at t equals 0, v is equal to 3. So they already gave us our initial velocities. We already know that c is equal to v0, or if you want, or if you don't know that, just simply plug in 0. Therefore, c is equal to 3, and therefore v is equal to 6t squared minus 2t plus 3. Okay. Now we're gonna include displacement over here. If at t equals 0, the displacement s is equal to 1. So we should know that the integral of velocity is equal to displacement. Okay, so we'll just simply integrate this formula we have here again. Okay, and now we'll just integrate it. So it will become 2t cubed minus t squared plus 3t plus, normally quantity is supposed to be x0, but right for now we'll just put c. And this is supposed to be equal to our displacement. Okay, now they said that the initial displacement here, over here, our initial displacement shows that s0 is equal to 1. Okay, and or simply when t is equal to 0, s is equal to 1. So therefore c is equal to 1. So now we have therefore s is equal to 2t cubed minus t squared plus 3t plus 1. And this will be this will be so much more easy. This will be so much easier if you are taking mechanics. I mean, you don't take integrals in mechanics, but I'm sure it's already, I'm sure it should be known that this is the fact that what I just told you. The second derivative of displacement is acceleration, and the first derivative of displacement is, wait, the second derivative is second derivative of displacement is acceleration, and the first derivative of displacement is velocity. Okay, now over here, this is no longer regarding speed or anything. We are given that fx is equal to the integral of 4 over square root of x, so we can rewrite this here as 4x minus half plus 10x power 4. Okay, so we'll just integrate that over here. Fx is equal to 4x minus half plus 10x power 4. We'll just, and this is the integral, of course. Now just simply integrate it here. Yeah, and we get 8, this, and this is equal to fx. Now we don't know constancy, but in order to get it, they gave us 1 point on the 1 point on this curve. They said that 1 point on this curve is when x is equal to 1. So set x equal to 1. It is equal, y is equal to 20. So 8 plus 2, 10, 10 plus c is equal to 20. Thus, c is equal to 10. And therefore, fx is equal to 8 squared root of x plus 2x power 5 plus 10. Now they just want to find f4. Now you plug in f4. You get 8 squared root of 4 plus 2, 4 power 5 plus 10. Now I'll put this on the calculator. And I get 2074, but I think that's wrong. Let me just double check. No, wait, it is correct. Okay. So it is equal to 2074. So over here, more definite integrals, super easy. I'll just rewrite a like this. And then first I'll derive the inside to become 2x power minus 4 over minus 4. It becomes minus 1 over 2x power 4. and in the range of values 1 over 2 and 1 over 4. Okay, so we put no, this time we'll put upper minus lower. Sorry, upper minus lower, like as in the input. So minus 1 over 2, 1 over 4, power 4, and then minus 1 over 2 half, power 4. And then on the calculator, we get... Okay, so over here it will be minus 128 minus, and then minus 8 here. And then over here, therefore, you'll get minus 120. So that means the answer in part A is minus 120. Oh, sorry. Finally. Okay, now in part B, we have to do the U method, the U substitution method. So we have minus 1, 1, 25x power 4, and then x power 5 plus 1 to the power of 4. Now, obviously, over here, we're not going to fully expand this. This is going to take far too long. Instead, what we'll do is set x power 5 plus 1 equal to u. We'll derive u. We'll isolate dx. So then we get dx is equal to du over 5x to the power of 4. And then we can rewrite this integral as minus 1, 1, 25x power 4, u to the power 4 du over 5x power 4. So first you divide by these two. 5 is a constant that you get. You take it out of the integral since it's a constant and you won't really change it. And u power 4 is just u power 4 du. And then you simply integrate u power 4 into u power 5 over 5. Oh, over here, look. Now we put minus 1 and 1, but this is wrong. You cannot set these boundaries. Why you cannot set these boundaries? What you can do instead is set these values. Sorry, I added the x. What we'll do here, we'll set u to x equals 1. And we'll get, so u is x power 5 plus 1. So it's going to be just 1 to the power 5 plus 1, which is equal to 2. So that means, well, as our new values, we'll put 2 and not 1. Since we're doing u and not x anymore, there's no x present here. So we might as well now turn everything into u. And now we'll do u when x is equal to minus 1. So minus 1 to the power of 5 plus 1, which is equal to 0. Therefore, over here, instead of minus 1, it will be 0. So now we have the new range of values 0 to 2. And you could just write 2 to the power of 5 over 5 minus 0, which is equal to 32 over 5. Or wait, that's an integer. Give me a second. Oh, wait, never mind. We're only doing the inside at the moment. We still have to multiply by 5 at the end. So over here is 5. And then you get 32 over 5 multiplied by 5. You cancel the 5s, you get 32 over here. And then final question. Simple integral. We'll first write it so then x is just in one power. X squared of x is just half. So it's like x squared, x half. And then when it's multiplied, you just add them. And then you get 2 plus half, which is equal to 5 over 2. So therefore, the exponent in total of x is 49 x power 5 over 2 dx. And then you do 49 x power 7 over 2 over 7 over 2. You get 49 2x power 7 over 2 over 7. And then you cancel, and you get 14 x power 7 over 2. And then over here, they show that they split it into 3 and half. 3 plus half is also equal to 7 over 2. So that means you can just safely split this into also x cubed squared of x. There you go. This is the answer. And the coefficient here is 14. And the coefficient here is 14. And you can't forget plus c, of course. when you're integrating an indefinite integral into an indefinite integral, of course. And we, of course, did not get a single mistake. Hopefully, this helped you. Speeding up the video would be nice. If you see a video that you think you might struggle on, then you can, of course, just slow it down from there. Other than that, I have nothing much to say other than thank you for watching, and see you on, and then I'll make another video for periodic. See you then.